This drill is a Chapter 5 test review. We're getting ready to start our last section, and I just thought I'd introduce a review drill now to kind of get you thinking about what we've done so far. So it tells us that the sides of a triangle, so all of these are right off of your test, so these are good practice questions. 34, 47, and 52. To the nearest degree, so we want to use degrees, what is the measure of the smallest angle? Well, remember, the smallest angle would have to be across from the smallest side, so it's going to be this one right here. This I could call this A if I wanted to. I can really call it anything that I want. And so I've got this angle that I want to find and the side across from it. And I have to remember it's side, side, side. So I'm going to use law of cosines. I can't use law of sines. I don't know a single angle. So I'm going to use law of cosines. So I'm going to have 34 squared equals the other two sides squared minus 2 times the 47 and the 52 times the cosine of A. Notice I've got the 34 and the A here. That's why we always highlight that to make sure those are there and there. All right, so I'm going to use my calculator now to help me. 34 squared, 1,156 equals 47 squared plus 52 squared. I get 4,913 minus 2 times 47 times 52, 4,888 cosine of A. And remember, every time I said you cannot subtract these because this is being multiplied by the cosine of A. So these are not like terms. You cannot combine those. So we subtract the 4,913 from both sides. Using my calculator, negative 3,757 equals negative 4,888 cosine of A. Now I'm going to divide both sides by the negative 4,888. Let's see, I'm kind of running out of room here. I'm going to have to move over to here. So let's see, the negative 3,757 divided by the negative 4,888 gives me this decimal that I'm going to write down. So I have that 0.7686170,213 equals the cosine of A. Then, since I'm solving for A, I have to take the inverse. Anytime I'm looking for an angle, I have to take the inverse. And so it says to the nearest degree, so that's the nearest whole number. I'm going to take the inverse cosine of 0.7686170213. And I get 39.77, which would be approximately 40 degrees to the nearest degree. Okay. Number 2, let's look at this triangle at the right. Notice this is a right angle. I labeled that. To the nearest thousandth of a degree, what is the measure of angle C? So I've got, now this is a right triangle. That's really important. Because when it's a right triangle, I don't need to use law of sines or cosines. I can use SOHCAHTOA. And what I've got to figure out is which one to use. So I want to find angle C. I know this side and I know this side. This right here I know is my hypotenuse. So I have the angle, I have the adjacent and the hypotenuse. which is a cosine relationship. So cosine of angle C, that's the one I'm looking for, is equal to 7, is the adjacent, over the hypotenuse square root of 85. So to find C, take the inverse of each side, and C equals the inverse cosine of 7 divided by the square root of 85. I'll be careful when I put this in my calculator. Oh, you know what I realized? I also have 6. I could have used 6. I think I'd rather use the 6, actually. You know what? I don't know why I didn't see the 6 here when I was doing this. I would probably have done inverse tangent instead and done 6 over 7. That would probably actually be a lot easier, so that I don't have to worry about a square root in the denominator and all my parentheses. So let's actually do that. I don't know why I didn't see that initially. So because I have the 6, and then I don't have to worry about square roots, I'm going to do tangent of C equals opposite over adjacent. So C is the inverse tangent of 6/7. I don't know how I missed that, but that's sometimes what happens when we're doing problems. So inverse tangent of 6 over 7. And I get 40.6. It says to the nearest thousandth of a degree. That would be 601. So 40.601. So C equals 40.601. Now, I'm not saying I couldn't have done it with this. I just think this is much easier to type into my calculator, so I used that. Number 3, use the above triangle from question 2. What is the exact value of the cosine? Okay, so we have the cosine of A. So the cosine of A would be adjacent, which is 6, over hypotenuse, which is the square root of 85. Unfortunately, I can't leave a square root in the denominator. I have to rationalize it. So multiply it by the square root of 85 over the square root of 85. So that's just a giant number 1. And I get 6 times the square root of 85, all divided by 85. And that's my final answer. Let's go to number 4. To the nearest thousandth of a unit, what is the value of x? And x must be, this side right here. And this angle is 50. So I know this angle, and this is the side that I'm looking for. And I have side, angle, side, so I'm going to use law of cosines. So it's going to be x squared equals 8 squared plus 10 squared minus 2 times 8 times 10 times the cosine of 50. Well, this is the kind that's much easier to do because there's no variable here, so I can type all of that into my calculator, which is what I'm going to do. 8 squared plus 10 squared minus 2 times 8 times 10 times the cosine of 50. So I get x squared equals 61.15398.245. And I take the square root of both sides. Don't need plus or minus because it's the side of a triangle. So the square root of 61.15398.245. And says to the nearest thousandth of a unit, so 3 decimal places, 7.820 will be the length of that side. What is the domain for the inverse tangent? Well, I think about that graph. Remember my graph for the inverse had the 2 asymptotes, and then it went like this. Well, my x's went forever and ever in both directions, so the domain is all reals.